The Mississippi River is the fourth largest river in the world, and with its tributaries, the Mississippi drains all or part of 31 states, or about 41% of the continental United States. This central artery of the U.S. connects the Great Lakes to the heartland to the Gulf. The U.S. Geological Survey is working with water, industrial, and agricultural groups, as well as cities, states, and federal and non-governmental organizations to better understand the river and monitoring data. One such collaboration is with the mayors of the Mississippi River Cities and Towns Initiative.
We are actually a group of 76 mayors from Minnesota to Louisiana who have come together to protect our waterway and make sure that the economies that depend on the river are more sustainable. We know in government especially what gets measured gets managed. Back in March of this year, the mayors signed a memorandum of common understanding with USGS, and we are working together to deploy a comprehensive nutrient monitoring network for the entire Mississippi River Valley. And that might not sound like what you would expect for a group of mayors and cities, but we do understand, and really it all starts with water quality.
The USGS historically has collected both discrete and continuous water quality data. Both discrete and continuous data have provided a rich foundation of information for science analysis, such as determining trends in water quality to assess the health of our nation's rivers and streams. Recent advances in nitrate sensors are now providing an opportunity to measure changes in concentrations many times per hour or day, and can be deployed in many types of rivers and lakes. The USGS has 3,894 real-time stream gauges in the Mississippi River Basin that monitor the flow in the Mississippi and its tributaries. About 60 sites have continuous monitoring for nitrates, and about 10 sites monitor for continuous phosphate, but some are temporary monitoring sites that are deployed for assessing site-specific nutrient issues. A dedicated long-term nutrient monitoring or supergauge network is needed that will provide a cost-effective, consistent, unbiased regional approach to evaluate the changes in nutrient loads. Significant resources are invested by farmers, industry, and the public to reduce nutrient pollution to the river, and a long-term network will help us assess the changes that are occurring. But setting up and maintaining these continuous monitoring supergauges is complex, as Elizabeth Murphy explains.
We're here at the USGS Continuous Nutrient Supergauge to collect continuous water quality. This site is on the Green River near Geneseo, Illinois. It's one of 10 such sites in the state where we collect these data.
A USGS supergauge is a gauge station with real-time continuous measurements of streamflow, other parameters such as pH, specific conductance, turbidity, and dissolved oxygen, and at least one chemical constituent such as nitrate or phosphate. Discrete samples of nitrate and phosphate are still collected, but the continuous nutrient sensors help fill in the gaps between samples. The supergauge also collects data when it isn't safe to collect discrete samples, such as during extreme flood events when the largest loads of nutrients are being flushed through the basin. Integrating cellular and satellite modems into the supergauge also supports remote sites and allows real-time data upload to the web along with remote system monitoring. The long pipes going down to the stream house the 4 instruments for measuring nitrate, phosphate, turbidity, and general water quality. The USGS makes monthly maintenance trips to most water quality sites to clean the sensors and calibrate them against known standards. This helps ensure that there have been no degradation to the instruments and data available on the web are accurate. Additionally, the hydrologic technicians collect samples at extreme flow events, high and low, to make sure the instruments are recording accurately at the extremes. The largest loads of nutrients to the river occur during storm and high flow events. Since the sensors are located at one point in the river, the technicians will also visit the site for periodic cross-sections of water quality. These measurements across the river will allow us to understand how the measurement at the instrument relates to variability across the channel. By monitoring and analyzing the nutrient data from a regional network of supergages, we are taking the first steps in understanding how actions by farmers, industry, and governments on the landscape are changing the conditions in the river, and the actions we may need to take to preserve this vital resource for generations to come.